Hello, my name is Bishoy Biawi. This is my demonstration for my final year project titled Content-Based Recommendation System under the supervision of Dr. Sringul Smith. This is an overview of the presentation content. First, we'll start with what is the content-based recommender system, then move to the project aim and objectives. Also provide a high-level architecture for the system and show the results of testing and evaluation. In addition, we'll show future work and then conclusion, finally followed by a list of references and a project demo. First of all, content-based systems. They are systems that analyze a set of documents or attributes that have been previously liked or viewed by the user, then use those items to build a user model which consists of the interests of the user or his preferences. Later, this model will be used by the system to match it against all the items or other items in the database and see if there is any match between the user model or the user interests and those items. If there is a match, then the system will recommend those items as they may be in the interest of the users. Therefore, the project aims is to build a content-based movie recommender system that will use a movie's metadata to recommend movies to the users. The project aim has led to the following objectives: research common content-based filtering algorithms, implement the cosine similarity algorithm to produce the meaningful recommendations, build a backend to connect to the front end and the recommender engine to handle recommendation requests, and finally build a front end app to display the recommendations to the users. This provides a high level of the system. As we can see in the diagram, it shows the four parts in the system: a front end, which will be handled by a server or autocomplete title to deliver the recommendation to the backend API. The backend API will call the recommendation engine, which will be calling the cosine similarity algorithm to generate recommendations and serve it back to the user. The whole project is connected to the MySQL database in the backend. After implementing the system, this was a testing and evaluation results. The test system has been tested for 3 cases. The first case for testing to see if the system returns movies from the same actors and genre. The example was Shrek. As we can see in the diagram, the results showing Shrek 2, Shrek Forever, Shrek the Third, and the cosine similarity degree between all of them varies. For example, between Shrek and Shrek 2 it's 0.64, Shrek and Shrek and After is 6.2. So the common thing between all of those movies that they are adventure, comedy, animations and family, plus they have the same acting team. The next testing case was to see movies return the same categories or character. An example for this was the Superman, and as we see, the recommendation results has returned 5 movies that talking about the Superman character or the Superman category with cosine similarity 7.2, 66 and 55, such as Superman IV, Superman the Second, Superman Return, Third, also Man of Steel. The final case of recommendations was to see if the system would return movies with the same story. For example, Ex Machina movie. The result shows the moon, transcendence, here, and space Odyssey. All of those movies are talking about artificial intelligence and genetic engineering. So that tells that the system is returning movies with the same story. Future work of the system. There are 4 points for future work. The first one is cloud hosting using Amazon Web Services. This will allow a security of the website, and the website will be available for more users to use. The second is the implementing in real life project, such as a TCTV. It's a video-based website for parenting, and I can implement the project in the TCTV to recommend similar videos to parents. Finally, we'll be evaluating the system using multiple attributes, such as date or length. The current system has been only developed using 4 attributes, so we can use more attributes to evaluate the system, such as the date of the movie was released, the length, the movie, or even the language. Conclusion: content-based systems. The system tries to match users to items previously liked by the users. The project aims to create a content-based movie recommender system. It uses a back-end API to handle recommendations between front-end and recommendation engine. System future development includes cloud hosting, real implementations, and evaluating the system using different attributes. And this is a list of references, Riki et al. And now we'll do a demo. As we see, the server is running on a local host port 500, and that's the front end of the movie. So if I put a movie as Shrek, you can see that the autocomplete titles connects to the backend to get us recommendations from the database. I click search, it is loading the recommendations. It displayed to the user, can see Shrek, Shrek 2, Shrek 2nd. The backend, you can see the process of the cosine similarity recommendations. If I click search again, we can see that the results went back because the system is using API caching, which appears here in the backend. That provides a faster response. If I search it for another one like Superman, and I click search, we can see that the system is loading the recommendations, and here are our recommendations again. Finally, if we search for Ex Machina, you can see that the system gives us the recommendations. Click search. Here are the recommendations. You can see Moon, other movies, they are the same, science fiction, drama, science fiction. They are all talk about the same idea. We can see here that the caching of the system is storing the results. So if I go back and search for Superman again, you can see that we got the results quickly because they were stored on the data, on the system caching. Okay, thank you very much.